This second video is all about kites. A kite is a quadrilateral with two sets of adjacent congruent sides. Now it's convenient for us that a kite, the way we think of a kite, meaning one that you might fly in the sky, actually is a geometric kite. Okay, but more generally, it's a quadrilateral with two sets of adjacent, meaning next to each other, congruent sides. So these two are congruent, and these two are congruent. Okay, and the same thing is true about this kite. These are congruent, and these are congruent. Okay, so the congruent sides are right next to each other. Now, properties of kites, a kite is a quadrilateral, so it has four sides. The sum of the interior angles is 360. The sum of the exterior angles is 360. Okay, a trapezoid isn't a parallelogram, rhombus, rectangle, or square, or even a trapezoid. So it doesn't have any of those properties. Okay. Now, one property it does have, again, a Geometry Sketchpad file. This is a kite. Okay. If I draw on the diagonals and measure some angles, these are the measures in and around E. Okay. So you'll notice that the diagonals are always perpendicular. Okay. And you can see that if you draw on the sticks on a kite that you fly in the sky, you'll see that the sticks are perpendicular to each other. And that's the first property of kites that I want you to know, is that if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, now that's a theorem in the textbook. Okay, the next two properties that I want you to know, or it's nice to know, are not theorems in the book. They're not even mentioned in the book, but I want to point out two other theorems that I've found useful as I'm finding angle measures in kites. Okay, so if I again draw on the diagonals and measure some angles, okay, let me just point out that ABE, this angle, is congruent to CBE, this angle. Okay, and CDE, this angle, is congruent to this angle. Okay, so the thing I want you to remember is that the diagonal that cuts the kite in half, okay, the very middle diagonal that cuts it in half, you'll see the AC does not, but BD kind of cuts the kite in half. Those bisect the angle, so angle B is bisected and angle D is bisected. Okay. Now that's not necessarily true about AC, okay, because BCE, this angle, and DCE, this angle, DCE, okay, are not the same. So this is 49 and this is 71 and they're not the same. Okay? But the thing you can notice right here is that BAE, this angle, is congruent to BCE. Okay, that those are the same. And that DAE is congruent to DCE. Okay, so anyway, you can think of these two. If I cut this in half this way, you can think of it as two isosceles triangles because they are. Okay, and so their base angles, meaning the ones that I've drawn in right by diagonal AC, those angles are congruent to each other. Okay, those are some nice things to know. And there's one more. Okay, in that BAD, this angle is congruent to BCD, this angle. Okay, that these opposite angles are congruent to each other. Okay, they look to be congruent, but the angle D and angle B are not necessarily congruent to each other. That's kind of summarized on this page, where the middle line bisects angles A and C. So the middle line, the middle diagonal bisects two angles, and these base angles in the isosceles triangles are also congruent. okay? And the angles in between the non-congruent sides, in this picture it's B and D, are also congruent. Okay, those are some other properties that you could use when finding angles in kites. So let's try a few. I don't think we'll do all of these, but we'll just do a few to get the hang of it. Okay, I'll call this one number 1. Okay, so I know that this angle is 64. Now, angle 1 and angle 3 are pretty easy because I know that the diagonals are perpendicular. So the measure of angle 1 is 90 degrees, and the measure of angle 3 is 90 degrees. Okay, now I just talked about the fact that the middle diagonal bisects the angles. So this angle right here is also 64. Okay, so 64 and 90 and angle 2 add up to be 180 because they're a triangle. Okay, so I will take 90 plus 64, and I get 154. And I subtract that from 180 to find the measure of angle 2. And I get 26. So the angle 2 is 26 degrees. Okay, and that's number 1. Number 2 is very similar to it. Again, the middle line, which I'm thinking of this as the middle line because it looks like it cuts the triangle in half, bisects the angle. So angle 3 is also 45. Angle 1 is 90. And angle 2, let's see here, angle 2, angle 1, and 45 degrees make 180 because they're a triangle, this triangle right here. Okay, so we'll add 90 plus 45, and I get 135. And I subtract 135 from 180, and I get 45. Okay, so angle 2 is 45 degrees. Okay, I'll skip 3 because it's very similar to numbers 1 and 2. Let's jump down to 4. Angles 1, 2, 3, and 4 are all 90 degrees. Okay, I hope that's kind of clear enough. Well, let me write it out. Angle 1 is 90. Angle 2 is 90. Angle 3 is 90. And angle 4 is 90. Okay, now I can find angle 10 because this is a triangle. So to find 10, I will add 90, which is angle 2, plus the 46 that I know, and I get 136. And I'll subtract that from 180 to find the measure of angle 10. 180 minus 136, and I get 44 degrees. Okay, so angle 10 is 44 degrees. Okay, now I mentioned the fact that this isosceles trapezoid has congruent base angles, and so 8 is also 44. Okay, and this middle diagonal will make it so that angle 5 is also 46. Okay, kind of moving around the triangle. Again, the middle diagonal bisects the angles. Angle 6 will also be 34. Okay. Now, this is a triangle. And so angle 1, 34, and 9 add to be 180. So I'll take 90, I'll add 34, I get 124. I subtract that from 180, and I get 56. So angle 9 is 56, and because this is a isosceles triangle, angle 7 will also be 56. Okay, that looks really confusing now. Okay, so here's a summary of the quadrilaterals that we've studied so far. So they're all connected to quadrilaterals, okay? And there's 3 kind of branches to the quadrilaterals. There's kites, there's trapezoids, and there are parallelograms, okay? It's 3 separate branches. Now, within each kite, there's no other kinds of quadrilaterals. A kind of trapezoid is an isosceles trapezoid, which we talked about in this section, okay? And with parallelograms, there are 2 types of parallelograms, well, 2 kind of branches from them, rectangles and rhombuses. And if a quadrilateral is both a rectangle and a rhombus, it's a square. Okay, so this is a really nice graphic organizer about quadrilaterals. I'd put this in my notes if this were me, because I think this is a really nice summary of the different types of quadrilaterals that we've talked about in these last couple of sections. Okay, and that's the end of this section. Hopefully you know the properties of trapezoids, the properties of kites. You can use them to find missing angles, and that you can use theorem 6-21 to write and solve equations with trapezoid midsegments.